First of all, I'd like to give a shout out to Courtney and Paige for coordinating this amazing event. And this venue is amazing. I never knew it was here, but it's really cool. So I wanted to talk to you guys today about how we set up a platform for data science teams and what we saw in the last 2 or 3 years as we did a lot of consulting. And we did a lot of research on the companies that were successful at becoming data-driven. So as you guys know, data science and data scientists means a lot of different things to different people. Sometimes when we talk to people about machine learning and deep learning, their eyes would kind of get crossed. And you know, I guess the most common answer is, oh, that's like IBM Watson or something like that. But how do we make that all work, and how do we add value to the business? So I wanted to share some feedback with you guys and answer some questions at the end. So just give you some background, some of the challenges, like I said, and some conclusions. So just a little bit about me. I'm in my early 40s, so I've been working in the IT sector for about 20 years now. Most of my career has been in the entrepreneurial consulting space. I've started a third company here in Atlanta. My previous 2 companies were in Latin America and Texas. And what we did in those companies was integrate supply chains, basically. So we dealt with oil and gas, finance and insurance companies. And in all of those cases, we touched upon many different company sizes and types across those verticals, and they all had things I'm going to share with you in common. That's a little bit about me. But what we did see at all these companies is that they all worked in silos. And a lot of these large organizations, especially post-financial crisis, went through a big wave of consolidation. And just a brief example of the challenges that were presented were, for example, Halliburton has over 200 ERPs in their organization, and each ERP is different, and each database is different that they're connected to, and getting all of that data centralized so that people can analyze it is a true challenge. So that's the other thing that I did was kind of a late bloomer here, but later on in life I decided to get my MCS, and one of the classes that I took was a data science class. And in this class, I was surprised at how much struggle was involved with both the students and the professors to set up their Jupyter Notebook environments, which is anybody, I guess everybody's familiar with Jupyter Notebooks? Oh, okay, like half? Jupyter Notebooks is a notebook type environment. Basically, it's a solution that grabs the console and webifies it. So it came out of Berkeley in the early 2000s. It had kind of a slow growth, but as of 2010, Fernando gave a speech at PyData in Europe and about Jupyter and its possibilities. It used to be called IPython Notebook, and now it's called Jupyter Notebook. And the reason, just not to get too off tangent, but the reason is because they decided to switch the kernel or the runtime environment to support multiple language runtimes. So they changed it from IPython to Jupyter to make it more language agnostic by brand. But in any case, both the professor and the students were struggling and spending an inadvertent amount of time getting the environment set up, getting sklearn installed, getting the right dependencies of R installed, getting the right framework installed. Does the container have access to the GPU, or does it not have access to the GPU? So when I saw that, I was like, okay, maybe there's something going on here. So we started to do some digging at some of these bigger companies and SMBs alike, and they all had these same challenges, but they were multiplied by a factor of many X. And not only did the people distract each other within teams, but the data scientists or business analysts would distract the data engineer, would distract the software architect, would distract the domain level expert. For example, hey, Mr. Data Engineer, I can't access the data, what's the password? Or hey, Mr. Software Architect or Mrs. Software Architect, what's going on with the Python environment that you set up? And so they would have to be taken away from what they were doing to support the data science team. So that's obviously very unproductive. So this is kind of the old way, and it's still very prevalent across multinationals. You have, and SMBs alike, you have a data scientist or data analyst, and then you have an IT manager that's there to support the data scientist or data analyst, and then you have the department teams, for example, the marketing or finance team, siloed away from both of these personas. And it's very difficult for somebody to come off the street, even if they have a PhD in advanced math and they know Bayesian optimization and things like that, to really understand the business and add value to the business if they're not part of that team and have the domain level expertise. So the analytics deliverable traditionally has been these sexy looking dashboards with bar charts and such, but they're very historical. What happened with the business previously, what people bought in Atlanta last year during the holiday season, and that's just no longer good enough. Big companies are getting killed by new upstarts that are reacting in real time. So this is, I'm sure you guys have all seen this Venn diagram. It's Conway's Venn diagram. Your ideal or typical data scientist is a mix of programmer, statistician, and domain level expert. How many here would consider themselves to be a data scientist? Do you guys agree with this diagram? Okay. But would you also agree there's other people involved in getting this to work? Like, for example, a data engineer or a software architect, or maybe a sponsor in the organization has, to make this happen. So the data scientist also needs to know how to speak and work with these other personas. So the new way of getting this to work from what we've seen is, and this, by the way, was shared with me last year at an event in New York by the people at Red Hat, and they did some consulting with their own clients, and they gave a talk about it. But what they had said at that time was that the data scientist was embedded within the team, day to day. So the data scientist would sit down with the marketing team and just become a marketing person, and become more of an expert with their wants and needs, what problems they were trying to solve. And they basically became a liaison with the data gurus, as we call them, which consist of analysts, data engineers, people that are experts in business intelligence, for example, that really know how to manage tools like a Tableau or Hyperion or Crystal reports. Also compliance people. How do the people in compliance have to deal with data governance and obfuscation and anonymization issues? And then the IT manager is really somebody there that's there to support everything, to lube up the wheels, if you will. So that's really what we've seen as a successful mini org chart for data science teams. So the new deliverable in the companies that we've engaged is the actual model to make a real-time prediction, or otherwise known as prescriptive analytics. I'm sure you guys have heard that term. Instead of doing predictive analytics, do prescriptive analytics. And as a software architect, I was always a big fan of let the developer use the language they're really good at using. And the talk previously caught my attention because they're kind of forced to use SAS. But a lot of developers will really fight that, and data scientists as well. Some data scientists would rather have Python and the tool sets that Python provides. Other data scientists maybe took the course, bioinformatics course on Coursera, and they like RStudio and R, and they're more productive with that. Some people enjoy Scala just because they're more used to working with Spark, and they're a big fan of the Java virtual machine, et cetera. And then the same thing is going on with deep learning frameworks. You have TensorFlow, Theano Cafe. I guess I should have put the Microsoft one in there, but I forgot. But everybody has a preferred framework to use, and we shouldn't be constraining people's productivity by tying them into one specific language or framework. At the end of the day, the deliverable is the model that will help the business react in real time. So a little things that we decided to do. The first kind of challenge that we saw at companies is that they really like to put things in a container. Everybody familiar with containers and Docker? Yeah, it's really cool. If you don't know it, I recommend it. One of the challenges, however, with Docker is that when you start collaborating with Docker and Nvidia, it requires specific drivers, and there's a wrapper for Nvidia called Nvidia Docker, but most people need to use Docker and Nvidia Docker in with a clustering system, such as Docker Swarm, Kubernetes, Mesos, et cetera. And a lot of these orchestration solutions don't support Nvidia Docker natively. So we came up with a little kind of a quick workaround. We can share the code with you. We have everything open sourced. But basically, the wrapper is a wrapper for the Docker run environment, and what it does, it just mounts the devices for the drivers, and the volume driver the Docker volume driver plugin declares the full path for those drivers. But you can mount them using either that curl command, because that port is the local socket once you have the NVIDIA installed, or you can just type everything out by hand. But that really helped a lot of companies start using these deep learning frameworks with GPU and Docker. Another thing I wanted to kind of mention, a lot of the feedback that we've gotten is a lot of this work becomes DevOps work. How do we automate training the model, and then testing the model, and then deploying the model to production? So this is just an example of one of the challenges that DevOps engineers face, and will continue to face down the road because this stuff is changing so fast. Last year we had everything implemented with this tool called Console, which is a key value store, and it basically advertised or maintained a store of where the containers were running regardless of the instance the container was running on. And so we had a reverse proxy that was polling that key value store and then routing the user accordingly to the IP and the random port where the container was published. But that was a very expensive setup. There was a lot of moving parts. And then all of a sudden, Docker Swarm and Kubernetes evolved quite a bit within the last year or so. And in the Docker's case, it came out with a new solution called Swarm Mode. Basically, it moved from Swarm Classic to Swarm Mode. And a lot of this stuff got baked into Swarm Mode. And now you can declare or create a service which runs tasks, and those tasks actually run the containers. And that's a great new solution. But like I said, next year, 6 months from now, next year, 2 years, it's just going to continue to evolve and continue to change. All of this is moving so fast. So once you have all of this set up and with your data science team, somebody's got to maintain it and keep it up to date. So that's kind of another challenge that companies face. And this is kind of the expression that a lot of our customers have. Oh my goodness, this is really cool technology, but who's going to take care of this stuff? This is just a brief kind of architecture diagram of what we did to solve the problem. We decoupled the back end from the front end, so we're called API first or integration first. I'm not trying to advertise our solution. I'm just trying to kind of let you guys know how we did it. And the React front end plugs in to a reverse proxy using these RESTful endpoints. And the CLI tools also plug into the same endpoint, so we only have to maintain basically one interface. And we have a Python stack in the back with Django, and then we connect to either Docker Swarm or Kubernetes to spawn the containers. And we can spawn either Jupyter notebooks with the kernels that they decide to use. You know, it could be a Jupyter notebook with TensorFlow. It could be a Jupyter notebook with sklearn, SciPy, whatever the user tries to use. RStudio, and there's other containers they could spawn, like Zeppelin. Zeppelin is a popular notebook solution with people that are used to using Spark. So we created this hub, we call it. It's kind of a play on words from the Jupyter team came up with a solution called Jupyter Hub, but we decided to call it Three Blades Hub. And Jupyter Hub is a great solution. It was a big source of inspiration for us, and we highly recommend it if you guys need a centralized solution to spawn containers. But you know, companies sometimes struggle with Jupyter Hub because it is an open source solution. It works on grants, and the support and upkeep isn't up to par for the enterprise. So the way Hub does it connects various data sources. It abstracts away the server management. Is it a CPU server? Is it a GPU server? How many gigabytes of RAM does that container have or have access to? What programming languages are baked into the container? So another big thing here is the data science team really has to enable separation of concerns. If there is an update that needs to be made to the container, which happens all the time, or if there needs to be an update to the model itself, let the model be updated without having to rebuild a full-blown container that has all of the dependencies baked in. So if you have all the containers separated into micro-containers, then that really helps facilitate management. It also allows the data scientists to manage their own container. As long as they have a binary installed within the container to manage sessions, then they can manage the container however they choose. Another important part, most large companies have the deployment part already solved, but a lot of small and medium companies don't. So they need to automate. Once they create the model, one of the people here from RentPath was telling me about a really cool model. They started tagging kitchens, the images of kitchens in their apartments webpage. And they're doing that with a deep learning model that they trained. And they can deploy it very quickly to production. But not all companies are built that way. You know, legacy companies don't have the culture, or I guess I should say the processes in place to be able to deploy models quickly. And the longer it takes for them to deploy a model, the higher the opportunity cost they have to deploy a model. So that's an important piece. And the notebooks, which enable exploratory data analysis, which is, you know, 80% of our time is focused on data munging. You know, it's not the most exciting job in the world to do all of that data munging, but it's something that has to be done. So in conclusion, provide flexibility with the tools that data scientists use for exploratory data analysis and visualizations. But I didn't mention it, but visualizations are also a diamond in a dozen. It's a very old sector. The BI space has been around for, gosh, 20, 30 years. There's tons of tools out there. They're all fantastic. And data scientists and business analysts should be able to tell their data story with the visualizations they choose. One central source for project files. They need to be version controlled, not only the models, but also the data sets, the notebooks that we use for exploratory data analysis need to be version controlled, otherwise it turns into kind of a nightmare. Everybody needs to tell a story with their exploratory data analysis. Gosh, what did I see here? Maybe there's excess bias. I normalized it this way, that way. And how do we train and save the machine and deep learning models with multiple frameworks in the same project? A lot of times a project isn't language or model specific. A project is, let's develop a churn rate predictor or an image recognizer, and let people add the languages and files that they need to make that happen. And like I said, streamlined deployment pipelines. So I always thought 25 minutes was a super long time to talk, but it just kind of goes by really fast. So I have a couple minutes for questions, and thank you. Well, what we've seen is that most people are used to Git, and the service providers that offer Git services like a GitHub or a Bitbucket or GitLab. So we've enabled our version control with Git. And so if you go in a project and you fork a project, we're actually creating a Git fork. And if you commit a new version of a file, we're actually creating a new Git add, Git commit in the background when you click the save button. And that in the future would allow people to roll back certain versions. It would allow review processes and things like that without too much trouble. We didn't want to rebuild the whole version control. Okay, so that is set up with triggers. So you can set up triggers. You can obviously manually click on a button and say, let's rerun this training model or set of functions. But in most cases, people want to trigger that. So when, for example, a new data set hits an S3 bucket on Amazon, that would create a payload, which would be sent to a webhook endpoint, and that endpoint would trigger starting a server, getting the data set, running the training model, saving the model, and then deploying it to production if they choose to do so. And it can also run through a set of tests if they want to automate the testing as well. Thank you very much.